able to, okay. So 1G, we know that, okay. 1G, we know that FDMA, right? One channel per one user, or else let's take one user per one channel, one user per one channel. Okay. So another one is TDMA. Right. This is another form of actually digital, which is can say, okay. So TDMA. Okay. So 8 users per one channel. Okay, 8 users per one channel. Then when it comes to GSM, okay, so here it is 2G, one is GSM. Means like here channel is channel allocation, frequency domain. Channel allocation is time domain, right? GSM. It is like TDMA plus FDMA plus TDMA, I can say. FDMA plus TDMA. Right, again, I can say here it is 8 users per one channel. Okay. So here time domain assignment. So another is there, right? The CDMA. Okay. So this comes under 2G only. So code-based channel allocation. Right. Code-based channel allocation. Let me go through. So why people thought code-based, code division, multiple access, code-based channel allocation. So what was the drawbacks of 1G and GSM? Okay. So here in 1G frequency, let us take, I am drawing. Okay. So this is the frequency time domain. Okay. 1G, right? Frequency domain allocation. Okay. GSM time domain allocation. Time domain allocation. But the problem is either we are able to assign the channel in time domain or frequency domain. Okay. Either we are able to allocate the channel in frequency domain or time domain, but not both. Now let me tell you what are the issues. Okay. So in GSM, what are the drawbacks? For example, here in a particular base station, we know that 8 slots, 1, 2, 3, 4, 5, 6, 7, 8 slots. But let us assume only one mobile is there. Only one mobile in entire base station, only one mobile is there. Then this is occupying the slot 1, right? And this total 7 are empty. Let us take in 24 hours, only one UE there. One user is there. Just imagine 7 means bandwidth wastage. Am I correct or not?
Yeah, okay.
For example, he is not using voice, right? Even with GSM plus GPRS, right? Data can also be accessed, right? So, for example, he means he wanted to access the at that time 10 MB is a very huge data rate. Correct. Let us take he was accessing 10 MB file. Okay. Example. So now 7 slots are empty, not able to use, right? Not able to use this bandwidth. Use this bandwidth. Correct or not? Because this fellow is stick to only one slot. So every time 144, 114 bits only transmitting. So to download 10 MB, it takes at least 5 to 6 hours. 5 to 6 hours to him. Got my point? 5 to 6 hours to him to download the 10 MB. But if we are able to assign this, means like entire bandwidth is not useful. Okay. So that's why people thought either we are able to assign the frequency or time, but not both. But not both. So then they thought only when one user is there, and let us take here 5 megahertz is there. Example. Okay, example, only one user is there, 5 megahertz is there, then entire 5 megahertz can be used by, in case one, so only one user is there, 5 megahertz is there, then 5 megahertz should be used by single user. Entire bandwidth can be assigned, to single user. Okay, this is case 2. Right, same 5 megahertz is there, right? 100 users are there. Then this 5 megahertz should be distributed to 1, 2, 3, 100 users. Got my point? Technology must be like, if 100 users are there, this 100 users should use the 5 megahertz, whatever the channel, not only 5 megahertz, channel, instead of I write a channel. So, which means a technology is required, like if there is only one, entire channel can be used by the single user. If 100 users are there, then 100 users should use the technology. 100 users should use the channel. Okay. I hope you got it right.
Nagendra, can you go back one slide up?
Hmm.
For the GSM, like yesterday we discussed, there is 8 user per channel, right?
Correct.
So in this particular scenario, you're showing like one user is assigned for the slot one. We have
Correct.
7 empty slots.
You know,
So
in a particular area in your village, okay, only one user has a phone.
okay, got it. Okay.
In that case, in 2000, era of 2000, right? 1 or 2 people used to have the phones in the villages, right?
Mm-hmm.
Correct or not?
Correct, correct.
So later on, people have purchased. I remember in my village, one guy he was having a big Motorola phone like this, very big phone. It is very big phone. And he's not a big guy. I don't know where he purchased. He is like it's like near to my house. I don't know where he purchased. There is a big phone in my, like, in area. He was having phone 2002, in 2002. So means like very few people are there, but bandwidth is right still waste. So that's why people thought there should be a technology. There should be a technology, right? For example, this time and frequency. So time and frequency both should be assigned to a user. And for example, only one user is there. If he wanted to use 24 hours, right? He should access entire channel 24 hours if only one guy is there. If 100 users are there, 100 users should use entire frequency and entire time. There is no restriction. There is no restriction. This part should be used. Means if I say this is the bandwidth, only this part should be used by user 1. Only this part should be used by user 2. No. Any part of the bandwidth, can be assigned to any user. Any part of the bandwidth can be used by any user. There is no restriction. Okay. So with this intention, CDMA has evolved. Okay. The CDMA is code division, multiple access. Okay. Code division, multiple access. Got my point. Code division, multiple access. So what they have done, they brought time, frequency, they brought the code access. Means now the channel allocation is done with a code. Channel allocation is done by code, not frequency, not frequency and time. This is the technology. So simply I can say the principle of CDMA, all the users can use all the frequencies at all times. Means all the users can use all the frequencies all the time. There is no particular right upper frequency, lower frequency. No. Wherever free, wherever bandwidth is free, you assign it. So that is the fundamental spin. So for example, how it look like. So when I talk Telugu, right in our class, there are people from people in this class. Telugu people are there, maybe Tamil people are there, Hindi people are there, those who speak English. If I talk Telugu people can only decode my language. It is a code. Language itself is a code. When I talk in Tamil, then Tamil people can only decode. When I talk in Hindi, those knows Hindi, they can only decode the Hindi, right? English, right? Those who knows the English. Means I am a base station. I am a base station, right? Simply, base station transmits the code language, right? So if Telugu, Hindi, right? English, okay? Right, Tamil or Kannada and so on. So it's like each one will be given a code. Means base station knows every language, you can say all codes. Means this will assign, right? You can Telugu, Hindi, Tamil, English, Kannada, whatever you say. Okay. So means code based channel allocation. Code based channel allocation. Let me explain you how things will be happened. Let us take, this is my bandwidth. Okay. Here, user 1, user 2, user 3, user 4 are there. Okay. So for example, base station is transmitting data for, base station is transmitting data for user 1. Okay. User 2, user 3, user 4, and user 5. Okay, let us take, base station has decided to transmit the data to, right, user 1. So somewhere here this place is transmitted for user 1. So but this will be convolved with the code 1. So already user with the code 1, code 2, code 3, code 4, code 5. Guys, give me a minute, I'll come back. So means code 1, code 2, code 3, code 4, code 5, right? User 1 is assigned. Let us take, base station has taken a decision that right? Here bandwidth is assigned for user 1, right? Maybe user 3, but convolved with C3. Then maybe somewhere here, user 2, right? Convolved with,
So it's like more public and private key concept, right? We use in the TLS nowadays, right? And people like, so every public key is there with the UEs and there's a private key to decode it.
are you talking to me?
Yeah.
No. That is different. Okay.
Okay.
That is a different concept. That is security
Okay.
concept. Okay.
No, I'm saying like that. We have a public key. It's code 1, code 2, code 3.
Public key,
That,
private key during the
yeah,
encryption. Correct.
yeah. So I was
Uh,
telling that the concept is look like that one. That's what I'm trying.
yeah, somewhat, but not exactly. Hello, Mandip, have you got?
Yeah. Sure.
Yeah, right. So then somewhere here, let us take UE4 convolved with the C4. Right, maybe this is again assigned to UE3 convolved with C3. So now this is transmitted. This is my frame or subframe. This is frame, subframe transmitted into the air. So what my UEs do, right? All UEs, right, search for their data. Right, when they receive this bandwidth, right, bandwidth will be transmitted into the air. Okay, this is the air transmission. Then each and every UE gets, okay. For example, here for UE there is no transmission. For user 5 there is no transmission. But how my UE 5 knows that there is no transmission? Right, it is not a human being, right, to see, and but there is a particular procedure. For example, UE 6 is there, UE 7 is there, UE, right, 100 is there, but data is only transmitted for these only 4. Okay, so how all this knows? They have to search. They have to search in the bandwidth whether they assigned, is there any data assigned for them, any bandwidth assigned for them. So let me take, right, once this transmitted into the air, right, all mobiles catch this bandwidth, then start searching. So let us take first this started searching. This has started searching here. So its code is C1. Its code is C1. But here it is C3. So C3 convolved, C1 convolved with C3. No, data is not decoded because mobile code is different. Bandwidth code in this area is different. Okay. So then it enters here. Let us take C1 convolved with C4. No, data will not be decoded. Right. C1 again, C1 convolved with C2. No, right, data will not be decoded. Then again, let's take enter here, C1 convolved with C3, right, no data will be decoded. Now finally it entered here, C1 convolved with C1, yes, data is decoded. Okay, data is decoded, which means whenever code matches, then only data can be decoded, right? If you might have heard correlation, cross correlation and auto correlation. So this is called auto correlation and this is called cross correlation. Okay, the concept of correlation and cross correlation comes here. Okay, so now let us take UE2. So UE2 is having a code C2, right? C2 convolved with, right, C3. No, data will not be decoded, right? C2 is convolved with C4. No, data will not be decoded. But C2 convolved with C2, right? Data is decoded. Right, again, means each and every mobile has to search entire bandwidth. So C2, right, convolved with C2 convolved with C3, no data. Okay. Then C2 convolved with C1, no data, right? No data. Okay. Again, oh, now UE3. UE3 is there. So UE3, C3 convolved with C3, yes, data is decoded. C3 is convolved with C4. Okay. So C3 is convolved with C4. No data. C3 is convolved with C2. No data. No data. But again, C3 is convolved with C3. Okay. Yes, data is decoded. Right. C3 is convolved with C. Okay. Okay. C1. Then no data. So like this means each and every UE has to search for their data in the bandwidth, right? By using the code, right? If code matched data will be decoded. For example, let us take this one. So C5 convolved with, or else let me take a different color for this. Okay. So C5 convolved with C3, no data. Okay. So again, C5 convolved with C4, no data. C5 convolved with C5 convolved with C2. Okay, no data. C5 convolved with C1. C5 convolved with C1, no data. C5 convolved with C3. So now my UE understands that, oh, this time there is no data for me. This time there is no data for me. So which means previously in 1G, right, frequency, particular frequency straight away. Frequency 1, user 1, frequency 2, user 2, straight away. There is no need to search nothing. GSM, slot 1, user 1, slot 2, user 2, slot 3, user 3, slot 4, user 4. There is no searching, nothing. Straightforward. Okay. But when it comes to CDMA, right? So, right now, this is the case when mobiles, 5 mobiles are there. So in case only one mobile is there, in case, right, here it is entire bandwidth, right, can be assigned to one user. So C1 entire bandwidth, right, user 1, right, convolved with C1. So that entire bandwidth can be assigned to this one if users are absent. So means entire bandwidth, if only one user is there, entire bandwidth can be assigned to user 1. If multiple users are there, right, divide the bandwidth in terms of their activity. Clear? This is what CDMA is. Got my point?
There is any code limit in this?
Yes. Theoretically, there is no limit. Theoretically, good question. Theoretically, no limit on codes, right? And no limit on number of users in CDMA. Okay, there is no limit. How many codes base station generates, those many users can access the network. Got my point?
Yeah.
How many codes base station generates, that many users can be accommodated. But when it comes to practically, right, what they have seen, practically they have seen theoretically no limit, even 100,000 users per bandwidth. But practically what they have seen, after 64 users, right, there is a floor noise increased for everyone. What does it mean? So for everyone, what does it mean actually? If 65th user admitted into the network, 65th user admitted into the network, when this fellow is allowed to use the network, then the 64 users, right, used to get the floor noise buzz like sound. If 64 beyond the 64, if anybody is allowed, means if users are allowed, right, a floor noise, some disturbance have seen for all the users. So that is the limitation. So that's why here 64 users, 64 users per channel, practically they limited. Okay, 64 users per channel, they limited, but theoretically there is no limit. So I remember still I was using CDMA. I never seen that there is a network busy, but GSM we used to see network busy
60,
because
64 per operational bandwidth.
sorry,
64 user per operational bandwidth.
yeah, channel is channel definitely will have the bandwidth, right?
But the, in CDMA, the user are using the entire bandwidth. So there is no channel concept.
No. See, bandwidth means what? Channel only, right? Always channel bandwidth. See, you have a road, okay, from A to B. You may have a single line. So the bandwidth is single line. Right, you may have, right, two lines. So here, what is the bandwidth? Two lines. Right, highways may have three lines or four lines, right?
But in CDMA, there is one line. No?
There is a
One line.
one line you are calling.
Yeah. In CDMA, there is only one line. Because
No,
every user, either single user or all
no, it is.
only complete bandwidth.
Ugravir,
Yeah.
let me. See, here it is 1G, FDMA. What is the channel bandwidth here? 30 kHz.
30.
GSM, what is the bandwidth? 200 kilohertz. Okay. So these are bandwidths only, right? Channel bandwidths only, right? Okay.
Yeah, correct.
These are channel bandwidth only. CDMA, right? 1.25 megahertz. This is also a channel bandwidth. Okay. WCDMA, which is 3G, right? 5 megahertz. This is also channel bandwidth only. Right, LTE, the maximum bandwidth is 20 megahertz. This is also channel bandwidth. 5G, 100 megahertz to 400 megahertz. This is also channel bandwidth. Okay. These are all channel bandwidths. Got my point?
Yeah.
Okay.
Yes.
Right. So the thing is, in 1G, I am assigning entire channel bandwidth to one user. In GSM, I am assigning a channel bandwidth to 8 users. CDMA, I am assigning this channel bandwidth to 64 users. Right? WCDMA, you can say 5 times or 4 times to 64. 4 into 64, approximately. Then 20. Generally, there is no limit more than 500 people, you can say. 500 or 1000 people. Right here, there is no limit. Everything is a bandwidth only. The thing is, right, to whom we are assigning. How many people are accessing. Clear?
One more thing.
Hello?
So in 1G, the user is assigning frequency domain. GSM is assigning time domain plus frequency domain. Is right?
Correct. All the bands here, whatever we are talking, they are frequency, time. Okay? Right? Only from CDMA, okay, CDMA plus WCDMA plus LTE 5G used to have a code kind of thing, right? And GSM 1G, right, is assigned in terms of time and frequency. I hope you got right now.
Okay.
Hello? Ugravir, you got it or not?
Yeah, got it.
Right. So, which means theoretically there is no limit on the number of users into the CDMA, but practically, right, they have seen that there is a when number of users increased. See, in a for example, in any classroom, right? If classroom is built only for the 40 people, if we arranged seats for 50 people, definitely there will be a crowd. If we arrange 40 people classroom, if we assigned for 60, crowd will be increases. Definitely there will be a noise. Correct or not? Sometimes in a classroom, if there is a section and B section, if one teacher wanted to club both A section and B section, you see how much crowd will be there. So similarly, in CDMA, there is a floor noise increases beyond the 64 users. So that is the barrier. And CDMA is the basis for all LTE, 3G, 4G, and 5G. Okay, that is the base technology for further technologies. Okay. So even though CDMA is not in use for now, but that is the basis. Okay, that is the basis. So let me go through how the technology, right? So here you can see codes, right? We are calling about codes, Walsh codes, W0, W1 up to 63, means W0 to W63. This is Walsh codes. Okay, you say Walsh codes. Got my point. So here also 25 megahertz, right? For the CDMA services also 25 megahertz, right? 25 megahertz assigned by the government. So here the channel bandwidth, the 25 megahertz divided by 1.25 megahertz is the bandwidth, right? Because more number of people expected. Okay. So now here it is, I think 25 channels we used to get. 25 channels, and each channel, right? Each channel, right? 64 users. 64 users. Okay. So now this look like, you can say your human voice will be around 3 to 4 kilohertz, which will be digitized, converted. Right after right error correction, right, there will be blah blah bits. After this, right, you can see this much. Then here it is the code generation. So your data will be convolved, right? I was saying user data convolved with the code. Okay, code 1, code 2, code 3, right? So 0 to 63, which means total 64 codes. Okay, 64 codes. Sorry, channels is here not 25, 20. Only 20 channels. Okay, you can divide and check. Right. So now, this will be, right, combined. All the 64 users data is combined and QPSK modulation, right? QPSK modulation, which means 2 bits per symbol will be transmitted. 2 bits per symbol will be transmitted. So this is the operation of IS-95, or you can say CDMA. Okay, I hope you got the difference, right? Technology, technically, what is 1G, what is 2G, what is TDMA, what is GSM, what is CDMA. Clear?
So code like parity bit.
It's a pseudo random code. Okay, it's a code, just it's a code language. That's it. One code is attached to the data.
Generated inside the BTS and EOP both. So both sides.
Correct. Inside during the modulation, before modulation, this code will be attached. In 3G, scrambling code is there, right?
Yeah.
That code similar, scrambling code in 3G, scrambling code in 4G, CRNTI, 5G CRNTI. So in CDMA code, 3G scrambling code, 4G CRNTI, 5G CRNTI. So these are all same code only, some code identity. Okay.
Yeah.
So when you are entering to your office, you should show your identity, right?
Correct.
Then only they will allow. And each and every employee, they used to have a different ID card and ID number, some different chip number. Correct or not?
Yeah, correct.
So
Same
similarly,
same code is available at UI side. So it's compare and allow.
I didn't get you.
So same code is available at UI side.
You should have the code, right?
Yeah.
See, you should have the identity when you are entering to your office. Like your office should have a recognition system. When you show ID card, gate should open. Okay, your office is a base station, you are a mobile. Definitely, code should be there. Without, that's why CDMA phones used to have a separate handset along. There was no SIM card, only handset. Correct, no?
Yeah, yeah, correct.
Right. So to generate the different code. Okay.
Got it.
Right. So here I can simply let me go through before proceeding. Right. So now WCDMA. So 3G. So what exactly the 3G? Okay. So it is a WCDMA. Okay. The technology is CDMA, but wider bandwidth. Wide band. I should not say wider, but wide band. Wide band CDMA. This is we call 3G. So what is the wide band? So in CDMA, the channel bandwidth is 1.25 megahertz, but in WCDMA, it is 5 megahertz. That's it. Okay. 5 megahertz. So tomorrow we'll see. Now, let me conclude. 1G, what is the bandwidth? 30 kilohertz. Okay. GSM, 200 kilohertz. Okay. CDMA, channel bandwidth is 1.25 megahertz. 3G, this both comes under 2G. Okay. 3G, right? 5 megahertz. Now, when it comes to LTE, right, this increased bandwidth, right, from 1G to 3G. But when it comes to 4G, right, they gone for the 15 kilohertz. Then 5G, they gone for the 15, 30, 60 kilohertz. Right, we'll see the fundamental why they have gone for it. Right, this is OFDM. Okay, why they gone for here? They increased frequency, but they reduced here frequency. Okay, we'll see why. Tomorrow we'll see why. Okay. Right, with this class, right, almost 10 classes, almost 10 classes are done. 10 or 9 classes are done. So I hope you are all interested to continue, right?
Correct.
Yes, sir.
Please call again
Yes,
later.
yeah.
आप
Right.
जिस व्यक्ति को कॉल कर रहे हैं
Right.
वह अभी
So
कॉल नहीं
almost I removed people, those who are not interested, those who are not joined in the class, right? I'm expecting that you are all going to continue, right? Slowly we'll move to LTE, right? So I'll call to one by one today. Okay. So I hope you got it right to finalize, to confirm.
Yeah, yeah, sure.
Right. Right. I am
One
expecting you
more
all.
thing.
Yeah.
So one more thing. So can you let me share the suppose tomorrow we'll take the class. So
Correct.
advanced topic name. Like
I will give you the index. No need to worry. Okay. In before only, I'll share you the index.
okay.
Okay. I'll give you the index. Right. I'll upload all the videos. Right. And you can access.
Okay.
So these are all
sure.
small things. Okay. Right. Giving you the material, giving you the videos. These are all small things. Even we are purchasing this database from my pipeline. It is too costly. Okay. So even we are paying for you. to access the database, right? We are uploading seamlessly. I think some of you might be already accessed. Okay.
Mhm.
So no need to worry. Other things are very small things. Okay.
Okay.
Right. Giving you the material, giving you the videos, right? Any other things. Those are all very certification. These are all very small things.
So
Okay.
will you support for that means resume preparation? No?
Those are all small things. That's what I'm saying.
Okay. Okay.
So whatever you required, we will try to do. Okay.
Yeah.
No
Yes,
need
sir.
to worry. See, if we help you, right? Many of our students are from the reference only. Here, Ugravir is from the reference and Asim is from the reference, right? So I think some others are also from the reference only. Okay, we help you to write to be in a better position.
Yes. Yes. Yes.
100% we will help you right to be in a better position because you are paying, right? You should be benefited. If you benefited, you will refer us. Our business will grow. It is not like that pay and we close your matter. Okay. Even after the course also you can ping me, you can talk to me. There is no issue. Okay.
Yeah. Yeah. Yeah.
It is like always win-win. Okay,
Yes.
if you win, definitely we will win. Right? This is all about mouth talk and all. Right?
Correct.
At least I'm expecting two people from each of you for the next batch.
Yeah. Yeah. Sure. Sure.
That's what I'm saying, right? If we don't support, definitely we don't. You don't refer. Then we
Yeah. Correct.
close our right trainings. So don't worry about that. We will support you. Right? We will be there for you.
Okay.
So my request is that we put efforts, you have to put efforts. Once again, you should become a kid while learning. That's it. You go back to your learning age, you learn, then only you will get concept. Right? Today I listened, tomorrow I forget, then that will not help you and me. Okay?
Yes, sir.
Right. Okay, then any other questions? You can
No,
ping
sir.
me if you have any other questions.
Yeah.
One
Sure.
next
Sure.
question. Nagendra,
Hmm.
what's the difference like this U testing and this node testing? Like, uh, means the theory is the same or theory is same, but
No,
how
no,
it?
stack, see, functionalities will be different, right?
Okay.
See,
Mhm.
teacher functionality is different, student functionality is different.
Yeah, correct.
Okay. So
Mhm. I think we lost you. Hello? Hey, whatever.
yeah, sorry, there is a power off. I hope you are able to hear me, right?
A
Hello?
little bit like,
Uh-huh.
hello?
Just
Let
powered off.
okay.
Yeah. See, right, definitely base station functionality, core functionality will be little higher compared to mobile. Mobile, I can say it's a dummy device. It follows the instructions from the networks.
Correct.
Okay, server client communication. Mobile is treated as a client. Network is treated as a server. Definitely, server do have a more control on the clients.
Okay.
So in run testing, you will cover
Sorry.
BTS protocol testing, right?
Yeah, we will cover. I'll share you the both the courses, right? Brochure in the group. Don't worry about that.
Yeah, yeah, sure.
Right? See, we have two boxes. Okay. We have UE simulator, we have network simulator. You can learn both UE side protocol, base station side protocol, even core side protocol. Got my point?
Yeah.
We teach you both testing, right? UE testing as well as base station testing.
IMS testing as
So
well.
I'm sharing the content, course content. you can have a look. Okay, so we have both simulators, UE simulator as well as base station simulator, so that you can either you can build two types of resumes. One is UE tester, even base station tester, core tester. But that depends on your capacity, learning capacity.
So in core, you are covering IMS testing, right?
Yes, we'll cover IMS also. Okay, I shared you the brochure. If you feel that if something is missing, just come back to me. We'll discuss. Okay,
Yeah, sure.
right.
Thank-
For now, I am closing. We'll see tomorrow. Okay.
Thank you, sir.
Thank you.
Right.